Okay, here we go. Anybody watching this recording because you went on the field trip, you can access this packet when you get back on Tuesday, or I put a copy up on Google Classroom if you want to print it out and do the notes right now. All right, here we go. Everyone here ready to roll? Take a look at part A. We're going to find X and Y. Just to let everyone know, you're going to see that circle, that little X there on most of the diagrams. That's the center. All right, so everyone knows that's going to be the center. Let's start out with angle Y real quick because I think that's the easiest to find. All right, angle Y. Anybody remember what type of angle I call that? Where the vertex is on the circle. You have a central angle where the vertex is the center, and then you have this type where it's on the circle. This would be an inscribed angle. Good. And notice where it's drawn to. If I follow angle Y, it's drawn to, what do I call this segment right here? That goes through the center. That's a diameter. Anybody remember that theorem? Put both together. Inscribed angle drawn to a diameter, automatically a right angle. Correct. All right. So anytime I have an inscribed angle that is drawn to a diameter, it's a right angle. Okay, and that's going to be a right angle. And then angle X, don't think you need a circle fact every time because you don't. All right, you guys can find angle X without knowing anything about circles and everything about triangles. Right, angle X, what am I looking at here? 180 minus the other two. 90 minus 40. And that'll give me a 50-degree angle. All right, I do want to write the fact we use, fact or facts that we used every time because those are going to go into our proofs once everybody gets back tomorrow, and you'll start remembering them easier if you write them down all the time. So here you go. How did we get angle Y to be 90? Angle Y to be 90. Here's the fact. It's an inscribed angle. An inscribed angle drawn to, where did we say it was drawn to? What do we call that line segment? Diameter. So inscribed angle drawn to a diameter is a right angle. All right, there's our theorem I want to use. Inscribed angle drawn to a diameter is a right angle. All right, good. One down, a lot more to go. All right. All right, let's go to part B. 92 degrees. What type of angle is it? Central. What do we know about a central? Because I want to label another part of this diagram too before I find X or Y. If the central angle is 92, so is the arc, right? If whatever the central angle is, it always measures, it's always equal to its arc measure. So this arc is also 92 degrees. That helps me now find angle X. We just talked about it, but what type of angle is X? I want to get repetitive today. Inscribed. Oh, how do you find it? We haven't talked about this stuff. How do you find an inscribed angle? Because it's not equal. The central angle is equal to its arc, but not an inscribed. It's equal to half the arc. So I'm not going to say it's equal to 92. I'm going to say it's equal to half of 92. 46 degrees, as you guys find that on your calculator. And let's talk about Y. There's really nothing fancy with Y. Just with 92, and then the rest of the angle there is Y. Both of them should add up to what? It's forming a little circle here. Yeah, there you go, 360. So 360 minus 92. Nothing fancy. $268. And here's what we used, the theorem or fact that we used. How do we find that inscribed angle again? Inscribed angle equals, how do you find an inscribed angle again? I just want to write the rule. Half the arc measure. Half its arc measure. Good work, good work, good work. Any issues yet? It's a grind today. It's a grind, but it's worth it. All right, part C. 32, what type of angle? Inscribed, so I can find its arc. Its arc won't be 32, though. They're not equal to each other. That's a central angle. So if the inscribed's 32, what about its arc in this case? Not 32, but double it. Double it. Good. 64. Why is it useful to know the arc? Because take a look at angle X. What do we call angle X? That's going to be central. Central angle equal to its arc. So that's going to be 64. Woo! Ooh, how about Y? Now we're going to get serious, huh? What about Y? It's not inscribed. First, I need everybody. Angle Y, not inscribed. Well, look, the vertex is on the circle. No. Make sure you guys are aware. Inscribed angle, both sides have to be chords. Watch, that's a chord, but let me highlight this little green piece here. That's not a chord, that's a what? That's a radius, all right? This, if I extended it, would be an inscribed angle, all right? So it's not inscribed, so I can't take half of anything. But whoa. Let me go back to something I just mentioned there. This was a what? What's that piece again? What's that piece too? What do you know about them? They're in the same circle, so they have to be. Why does that help you out? What type of triangle did we just have now? Isosceles. What's across from those congruent sides? Congruent angles. Yes, and you already know X is 64. And you know the other two angles in that isosceles triangle have to be congruent. Get to work. Yes. All the radii in a circle are always congruent. So we got 180 minus the 64 we just found. Cut it in half because they're both equal. Hopefully we're getting 58. All right, ready? What do we use here? How do we find angle X? Central angle equals what? How do you find a central angle? How do we know it was 64? It's always equal to its arc measure, not half. That's inscribed. It's equal to its arc measure. And then the second thing, how did I know that was isosceles? Be careful. I remember all radii in a circle is false. It's got to be in a circle, they're all congruent. All good? 3 for 3 here? Yeah, I'm having fun too. I know, me too. Let's go. Let's go. All right, now hopefully after I've done 3 with you here, get in the habit of starting to write things on your diagram. I know everybody just looks at X. I got to find X. I got to find Y. Yeah, hey, we'll get there. We'll get there. But you can also fill in other parts of your diagram that you know are true that might get us to X and Y. Like I see 80 right now. What type of angle is 80? It's central. So automatically I'm writing an 80 on this arc that it's drawn to right here. I know that arc's 80. I don't know if it'll help me, but hey, it makes my paper look better, right? Oh, I think it does help me, doesn't it? Helps me find angle Y. What type of angle is angle Y? Inscribed, and everyone see it's drawn to the 80 degrees we knew about. So it's not equal to 80. It's going to be equal to half of 80. 40 degrees. Ooh, how are you getting the X? Anything with X? It's not inscribed, right? Because it's not 2 chords. It's a chord and a radius, so I can't take half of anything. But you see an isosceles triangle? Me too. Radii are congruent, specifically those 2 radii. They're congruent. And we know the angles across are equal. So we should be good to go now with angle X. So we're doing 180 minus 80. Cut that in half for the two angles. 50 degrees. Okay, two facts we used. I know. Why are we writing them down over and over again? Because they'll be ingrained in your mind. That's why. Okay, first thing, inscribed angle. Just the inscribed angle rule. Inscribed angle equals half its arc measure. And then how do we know that was isosceles? In a circle, all radii congruent. All right, come on now. For part B, can you fill in anything on your own? Anything. And then maybe we'll get to angle X. Angle X is inscribed. Maybe, I don't know, maybe we can use that, but you got the 160. Mark your diagram with things you know are true. And just so, I don't know how it looks on your paper, but that whole angle right there is 160 right there. That whole angle there is 160. All right, my first thing is nothing to do with circles. Can you guys find the angle next to 160, I hope? You know they're supplementary. Linear pairs are supplementary. So the angle next to 60 should be 20 degrees right there. That's 20-degree angle. Anything else you put in that diagram, I hope? Maybe? Maybe we're not there yet, but we will be. Anything else still? That inscribed, hey, look over here. I got an inscribed angle drawn to a diameter. That allows me to put a right angle. Now this problem's pretty easy because I have 2 out of the 3 angles in a triangle. So I got 180 minus 90 minus 20. I got 70. And the fact we use, let's keep writing it. How do we get that 90-degree angle? That circle fact we use. Inscribed angle, angles. Drawn to a diameter. Are right angles. Anybody wishing they took our science today? Just go outside your house. It's fine. Don't worry about it. All psyched up? Yeah, me too. All right, me too. All jacked up about the eclipse. Nobody? Going? Take a little break here? Nobody? Excited? No. I got extra glasses back there for my first period class. If anybody needs them, snag one on your way out. Go ahead. Okay. All right. Good talk. All right. How about F? Anything you want to fill in the diagram on your own? What's 58? That's a central angle. Oh, okay. If that central angle is 58, looks like I'll be able to label that arc as 58. But is that X 58 though? Just say, hey, also, somebody had asked me this in period 1, which is a good point. I'm not making, those arcs don't mean they're congruent. I'm just showing you what angle is 58 and what angle is X. All right, so don't get nervous that those angles are congruent because they're not. What type of angle is X? Inscribed, right? So it's not equal to its arc. We know we're going to take half of 58. and end up with 29. And how do I know it's half? Because inscribed angles equal to half its arc measure. Anything you're putting on the diagram for this one, G? Hopefully. Forget about X and 3X. What can I put on this diagram right away? A right angle. Yeah, a right angle. I can look right here, inscribed angle drawn to a diameter. And now, I don't know, hopefully this problem's a little easier because you got 3 angles in a triangle that add up to $1.80. So I got 90 plus X plus 3X, give me 180. And don't get nervous. Is this the one? Yeah, don't get nervous. You get a decimal. It's okay. $22.5. All right, you guys know the deal. How do we get a right angle there? Should become second nature now. There is a benefit being here today. Inscribed angles drawn to a diameter. Are right angles. All right, H, something not new today, but not new to you guys. New for me to review, but we have not gone over this fact yet. All right, let's go. Angle X. Well, if that's 260, can you guys find the one that makes up the rest of it right here inside that figure? So 260, what's across from it here? Not angle X, but what I mean by across is how about the rest of that angle right there? 100, right? Because they add up to 360. So I put a hundo in there. All right, let's review this theorem. Everyone see the quadrilateral that's inside the circle? Anybody remember the theorem about its opposite angles? If you have a quadrilateral inscribed inside a circle, anybody remember anything about the opposite angles? They are always, not congruent, supplementary. All right, so anytime you have a quadrilateral inside a circle, the opposite angles are supplementary. Supplementary. So X equals 80 here. Ready? Here's the theorem that we used. Quadrilateral, I'm just going to abbreviate it, quad. Quad, a quadrilateral inscribed in a circle. If you want to use the little circle notation, that I showed you day one, I'm not a big fan of it. Quad inscribed in a circle implies, there's your arrow, opposite angle supplementary. All right. Anything you want to put in for I here? I'm asking you to find angle X, which looks like it's inscribed. Well, if that's 214, you guys can find the rest, right? I see a lot of you going to the calc here. So if that's 214, the rest of the angle would make up 146, this one right here. And that also makes what type of angle is 146? Central. So if that central angle is 146, so is the arc, which leads me to inscribed angle x. Not 146, but I see everyone going to the calcs again. Hopefully you're taking half of 146. What do we use? Inscribed angle equals, again, yes, again, you're not going to forget it anymore, equal to half its arc measure. Hey, finally some good news today. I know you were having a lot of fun. I have not taught you enough to do letter J. All right, I have not taught you enough in this circle unit yet to do this. So we're going to skip this one and skip L because I have not taught you enough on how to find all the variables. I'm sure you could find a couple, but not all of them. But you can do K. So why don't we go to K now? So you're welcome there. Not enough info for J or L, but we certainly can find K. Digging deep here. I gave you inscribed angle of 35. What else are you filling out? All right, hopefully we're putting, if that's 35, you know the arc across is 70. Double it. If the arc is 70, so is the central angle. And why is that helpful? We just learned if I have a quadrilateral that's inscribed, those opposite angles are supplementary. What did we just use to find that 110? Quadrilateral. Inscribed. Yep, let's go. Quadrilateral inscribed in a circle implies opposite angles supplementary. Questions? All right, before I go on, last chance. Any more Eclipse talk? Or are you good? Anybody think of anything else they're excited about? Or okay. Anybody headed out? Big watch parties today? No, nothing. Corner of your room. Hopefully, it'll go a little dark for a minute and go back to light. Okay. Don't look up there, right? Use your glasses. Don't want your eyes to burn out of your head. That's what they say, right? If you do look at it, make everybody scared. All right, moving on. You guys are party animals, I can see. All right, this is going to be a new one. All right, I say new today, new to review, but we've already had this one. Angle X and angle Y. Let's start with angle X. I know it's inscribed. We can all agree there. Do you notice the 41 degrees above it? Everyone see that's 40, that's inscribed, and see where it's drawn to? The same arc that X is drawn to. So if they're both inscribed and they're both drawing the same arc, they have to be congruent. So this one, X, I know no calculations needed in my calculator, got to be 41 as well. Same thing goes for Y. Y is inscribed, and so is that 38 degree angle. They're both drawn to the same arc, they got to be congruent. So here was the fact we just used, used in a proof a lot. Two inscribed angles which those were 2 inscribed angles. Where are they drawn to? Not a diameter this time, but Lily? Same arc. Yep, 2 inscribed angles drawn to the same arc. Are congruent. So there's a new review fact. All right, B. Can we find X right away? X inscribed. So is 32. We notice, hey, they're both drawn to the same arc. Perfect, they're congruent. So X is 32. I can't do that for Y, unfortunately. I gotta find Y another way. So I'm gonna leave that up to you guys. However you wanna find Y. There might be a couple techniques to find it, but whatever you're comfortable with, doesn't have to involve circles at all. I don't know how you guys are getting into it. Me personally, I did. I found the angle next to 97. Was that 83? So that's 83. I already knew X was 32. And now I set up those 3 angles, including Y, have to add up to $1.80. Let's see, what did we use here? What circle fact? I think we used, how do we get X equal to 32? Again, 2 inscribed angles drawn to the same arc are congruent. All right, you guys get to angle X now. On part C, you guys get to angle X. All right. So 30 inscribed. Hopefully we put a 60 here, because it's always half. You want me to find X, which is a central angle. So it's always equal to its arc, 60 degrees. Fact we use, central angle equal to its arc measure. All right, see what we can do for D. I'll talk while you're working as well. W and X. W and X, both the same. W and X, what both are they? They got to be. W and X are both equal to each other. Inscribed angles drawn to a diameter, right? 90. So they're both 90. All right, I don't know what Z and Y are going to be, but I know they're going to be congruent. Anybody see why they're going to be congruent? Z and Y? They're both inscribed angles that are drawn to the same arc. So I don't know what you guys can find out what the degree measure is, but at least I know they're both going to be congruent to each other because they're both inscribed angles drawn to the same arc. So I'll let you figure out a method to find those. Don't overthink it. All right, don't overthink it. Fill in whatever you can. Here's, I don't know how you guys went about it. I saw that this triangle right here, I knew all three angles added up to 180. So I said, all right, 180 minus the 90 minus the 29 and also the 34 to get the rest of that angle. So also make sure you subtract out the 34 because that's part of that angle. And I have no way to get there. 27? 27 degrees. So if you got 61 degrees, make sure you subtract out that 34. All right, some of you might have got 61, which is this full angle 61, but I got to subtract 34 to get Y and Z. All right, what do we use here? Two facts. Inscribed angle drawn to a diameter. Inscribed angle drawn to a diameter. Is a right angle. And then we used, I knew Z and Y, angles Z and Y were going to be equal because those were inscribed angles drawn to the same arc are congruent. Whew. All right, go ahead. E. I'm going to start letting you guys do more and more on your own now without my help. Finding angle X. Try to fill in more if you can. You guys finding the angle next to 78, 102? Second or third time we use this fact, if I have a quadrilateral inside a circle, opposite angles are supplementary. So that's got to be 78. They're going to add up to 180. The rest of it, which is X, all right, I know they add up to 360, those two. So 360 minus 78. 282 degrees. Fact that we used, how did I know that was 78? Quadrilateral, inscribed in a circle, implies opposite angle supplementary. Whew. Guys ready for F? Anybody adding anything? I want to ask you guys, what are you adding to the diagram here before I find angle X that you're positive of on that diagram in F? Anything you can add, you're adding in, whether it be a circle fact or anything in general. 17. Hey, I got isosceles triangle up top, right? Good, I like that start. So if this angle 17, across from the other congruent side's got to be 17. All right, I got that. Nice job. Everyone good so far? All right, look at the angle I'm asking you to find, X. What type of angle is it? Let's start there. What type of angle is angle X? That's in inscribed, so it's equal to whatever half its arc across from it is. Now take a look here. It's not, take a look at the arc across from it. It's this one right here that I'm going to do in orange, or not. Maybe I'll just try that again in orange. If you guys can help me find what that arc is, I can take half of it and get angle X. All right, well, go back to those 17s we just found. Aren't those 17s inscribed? So the arc across of them will be equal to 17 or no? Nope, it'll be double, right? So 34. And then also over here, 34. So I won't be taking half of 17, or half of 34. I'll be taking half of 68. Everyone see how we found both those arcs were 34 and y? And then we're taking half of them combined. So yes, the answer does come out to be 34 degrees. Let's see. Inscribed angles equal to half its arc measure. What do we got? 08. This is period 2. All right, I think we'll end it right there. Okay. Make sure you bring this back because I'm going to start with there's a proof. The last question is a proof, and I'm going to start class with that tomorrow. No assignment tonight. Okay, no assignment. Thanks for grinding away here with me.